This class we discuss about application of Newton-Raphson method in load flow study. Let us consider two functions with two variables. f1 of x1, x2 is equal to c1, equation 1. f2 of x1, x2 is equal to c2, equation 2. x1 naught and x2 naught be the initial approximations. Del x1 naught and del x2 naught be the values by which the initial approximation differ from the exact solution. I can write f1 of x1 naught plus del x1 naught, x2 naught plus del x2 naught is equal to c1, equation 3. Similarly, f2 of x1 naught plus del x1 naught, x2 naught plus del x2 naught is equal to c2, that is equation 4. I write the equation 3 and 4 in the Taylor series, that is equation 5 and 6. 5 and 6 I can rewrite the equation, that is equation 7 and 8. Equation 7 and 8 can be written in a matrix form. This is the matrix form of these two equations. This matrix is the Jacobian matrix, that is dou f1 by dou x1, dou f1 by dou x2, dou f2 by dou x1, dou f2 by dou x2 with the initial approximation of x1 naught and x2 naught. Now I can easily calculate del x1 naught and del x2 naught, that is equal to inverse of the Jacobian matrix into this matrix. I can easily calculate del x1 naught and del x2 naught. The next approximation is x1 naught plus del x1 naught, x2 naught plus del x2 naught. Okay. In the same way, I apply the method in the two-bus system. We know that real power P is equal to E into V by X into sin delta. Reactive power Q is equal to E into V by X into cos delta minus V square by X. I derived these two equations in my previous lecture. Okay, please refer. Or I can write P is equal to F1 of del comma V. That is equal to this equation. Reactive power Q is equal to F2 of del comma V, that is equal to this equation. This is equation 1, this is equation 2. Now I can write del P naught. This is equation 3. Del Q naught is equal to equation 4. Equation 3 and 4 can be written in a matrix form. This is the matrix form of equation 3 and 4. This is Jacobian matrix. So I can calculate del naught, del V naught, that is del P naught and del Q naught into inverse of Jacobian matrix. Del naught and del V naught are then added to the previous estimates of V and delta to obtain new estimate of V and delta to start next iteration. In two ways we can solve the load flow equation using Newton-Raphson method. One is rectangular coordinates, another is polar coordinates. Polar coordinates is widely used to solve the load flow equation using Newton-Raphson method. Here Pi and Qi are the real and reactive power injected in the ith bus. These two equations are called as static load flow equations. Pi is equal to F1 of delta comma modulus of V. Qi is equal to F2 of delta comma modulus of V. Pi and Qi are the functions of two n equations. Any one or more quantities changes, the value of both Pi and Qi changes. The change in modulus of V and delta can be written with the help of Taylor series. Equation 1 and equation 2 are the Taylor series. Here I is equal to 1, 2, 3 up to n. Delta Pi is equal to real power specified minus real power calculated. Delta Qi is equal to reactive power specified minus reactive power calculated. In load flow studies, there are three buses. One is a slack bus. Known quantities are V and delta. Unknown quantities are P and Q. Second is a generator bus. Known quantities are P and V. Unknown quantities are Q and delta. The third is a load bus. Known quantities are P and Q. Unknown quantities are V and delta. Any one generator bus is considered to be a slack bus. Bus 1 is considered as a slack bus. In the equation 1 and 2, I neglect the term delta 1 modulus of V1. In the equation 1 and 2. After neglecting these two terms in each equation, I got the equation 3 and 4. Equation 5 and 6 are the general expression of equation 3 and 4. Here I is equal to 2, 3, up to n. Now delta modulus of Vk, I can write for my convenience modulus of Vk into delta modulus of Vk by modulus of Vk. I substitute this in the equation 5 and 6. I got the equation 7 and 8 like this. Equation 7 and 8 can be written in a matrix form. This is for n-bus system. This is a Jacobian matrix. The Jacobian matrix gives the linearized relationship between small change in voltage angle and voltage magnitude with a small change in real and reactive power. This is the condensed form of this matrix. The size of the Jacobian matrix is 2 into n minus 1 by 2 into n minus 1 for power injection subjected at n minus 1 buses. Size of J1, J2, J3, J4 are n minus 1 by n minus 1. Jacobian matrix is usually a non-singular due to diagonal dominance in each quadrant. Next class we will derive the elements of Jacobian matrix. With this I conclude my lecture. Thanks for listening.